Mr. N.S. Rathnayaka talking on modification of ID3 algorithm to explore student performance with their attributes. Mr. Rathnayaka is one of our own, is a lecturer attached to our Department of Information Technology and Mathematics at KDU. He completed his BSc Special Honours degree in Mathematics with second class upper at the University of Ruhuna. He is following MPhil currently at University of Colombo. His research interests are in numerical methods, computational fluid dynamics, and data mining, computer engineering and mathematics combination. Yeah, Mr. Rathnayaka.
Good afternoon, everybody. I'm Rathnayaka and my supervisor, Dr. Jagat K. Vijayaratna. The presentation topic is modification of ID3 algorithm to explore the students' performance with their attributes. This is the presentation outline: introduction, research problems, literature reviews, methodology, attribute selection measures, improved ID3 algorithm, conclusion and the recommendation which are developed the algorithm, and the further work which we are going to do. So this is the introduction about the why we want to do this one. You know that high amount of data stored in educational database is increasing rapidly in any educational institute, right? So this data set may contain more valuable information that can be utilized to improve the students' academic performance. In the field of education, the object of the classification is the categorization of the data for the most effective and efficient utilization. When you talk about the classification, it's actually one of the leading techniques in the data mining process which can be applied to accurately predict the target class for each case in data set. So under the classification, actually decision tree is the most important method of the classification in data mining for facilitating decision making sequential decisions problem in historical data. We have a lot of decision tree algorithm under that example ID3, as well as C4.5 or with the cart, chart, etc. Under that we consider about the ID3 algorithm. That algorithm is developed by J. Rose Colley in 1986, and that algorithm can handle only the complete information. That means if you have the missing attributes, that algorithm does not support for that. As well as a discrete attribute we consider it. As an attribute selection criteria, the algorithm is used information gain. These are research problems. The information gain, when we consider about information gain of the ID3 algorithm, actually the ID3 algorithm selects some attributes which are not necessary for the decision making. So to overcome that trouble, we want to develop this ID3 algorithm. This is a literature review we considered, sample literature reviews. The first literature review, actually, according to the information gain, they consider about the distant matrix as an attribute selection criteria. And the second one, another improvement of the ID3 algorithm considered, but that paper does not discuss about the accuracy. They are talking about only the decision rules. And the third one, there are not any improvement they are talking, but they are comparatively analysis the three decision tree algorithm, ID3, CART, as well as C4.5 algorithm, and out of that they consider about the CART is a better algorithm. This is the methodology we consider to analyze the algorithm, or maybe the implement of algorithm. We need the data. We collect data from engineering faculty, KTU. Later on, we introduce the coordinate system for each value of the attributes for easy calculation. Then we improve the ID3 algorithm. We write down the MATLAB programs for the improved ID3 algorithms. Finally, we are going to comparatively analysis both algorithm ID3 as well as improved ID3 algorithm. When you talk about the attribute selection measures, so entropy is most important part. When you talk about the mathematical function for the entropy, for the random event C1 to Cm, we define input equation. Here CID is the set of the instance of class Ci in dataset T, as well as modulus of D is a number of instance in D, and modulus of CID means the number of instance in CID, that means the class value. Then the ratio of that is the probability of the class Ci. This is the distribution of the entropy. When you talk about the one attributes, family income, actually there's a numerical attributes. We consider about that is a categorical attributes. It may be medium, low and high. You see the middle branch, already pure information we have, all the value is 15. Because of that case, we get the 100% pure, that means the entropy value is 0 of that. The right hand branch, you can consider about the equal distribution we have, that means highest entropy value we have. All the values between 0 and 1 you can see. Then next measurement we need to find out information gain is related to entropy. When you talk about the attribute A with the V number of partitions, we can define the relative entropy function like this. Information AD, the smallest expected information required for the greatest impurity of the partition. This is the information gain, the difference of the original entropy of the data set as well as relative entropy of the data set. This measurement is highest, so we consider that that is the attribute we need to split at first. This is the coding system we introduced for the 7 attribute, as well as first column you consider about the categorical class which you are going to observe. If the GPA value less than 3, we consider 15, as a greater than 3, we consider 14. But somehow 2 categories we considered. Then as an attributes, we consider about there is a second column to end of the columns, we consider 7 attributes, and we coding system is introduced. This is a sample data set we considered. We introduce a coding system for each attributes, you can see. Then we can apply this data set for the existing ID3 algorithm to find out the entropy value. That entropy value we get 0.9495 bits. Right? 2 class values we have. Yes will be indicate about the SGP value greater than 3. No will be indicate about the SGP value less than 3. When we consider about the family income as an attribute, then we can find out the relative entropy for the attribute family income. That value is 0.8213. The difference of that information gain of the attribute A, we got that value is 0.1281 bits. Similar process we can apply to find out the information gain for the other attributes. You can see the last column of the table that will be appear, but the highest information gain value consider about the family income. Because of that case, the first splitting knot of the tree consider the family income of the tree. This is the output of the existing ID3 algorithm we obtain, as well as we consider about the 2 rules, decision rules. It will be indicate if the family income is medium, that means indicate by branch 9. Department is electrical engineering, indicate by branch 7. Then SGP value is high. As well as the second rule, we get the family income is low, indicate by branch 10. And the department is mechanical engineering, that people is getting the low marks, low SGP values. What will be indicate of that? So then the students are motivated to select the particular department because the student targets to get in the high score, or maybe the SGP value is getting the class, right? So there may be the big competitions to select the particular department. That is the problems of the existing ID3 algorithm have, right? Then we are going to find out the solution for that.